Welcome back. In our next learning target, we're now going to take what we learned from 3.1, solving inequalities, to what happens when we have more than one inequality joined together. That is called a compound inequality. So by the end of the lesson, you're going to be able to solve and graph these compound inequalities that describe specifically a union. So let's first define what a compound inequality is. It's an inequality joined together with or and to form a union or intersection. Now you may not know what those two things are yet, but we will get to those definitions. And now first let's look at a truth table. So a truth table is taking two things, and that's what we're looking at, two different pieces of information joined together and seeing whether they're true or false. So I've got two categories. I've got A and I've got B, okay? A in the first row is saying A is odd and 4 is even. Is A true? Is 3 an odd number? Yes, that is true. How about B? Is 4 an even number? Yep, that is also true. So when I'm looking at this idea of or, I'm going to highlight the word or. If I can go here or there, I can go to either place and it be okay. So in the same way with this information, as long as one of the things is true, then that or statement, A or B, is also true. So because 3 is odd and 4 is even, then we can say that this is true. One or the other is true. Let's take that was this first row right here. Let's take a look at the next row. So this is saying A is 3 is odd. Is 3 an odd number? Yes, 3 is odd. B, is 4 odd? No, that is false. 4 is an even number. So now when I look at A or B, true or false, is A true or B true? Yes, A is true. So that means that the compound inequality together, A or B, is also true. Okay. The third row says 3 is even. Well, that's false. 3 is odd. So that doesn't work for the truth in A. How about for B? 4 is even. That is true. 4 is an even number. So when I go to look at A or B, is either one true or false? Yes. B happens to be true. 4 is even, so I can say that this statement is true. A or B is true. And for the last one, the last row, A says 3 is even. Well, that's false. 3 is odd. B says 4 is odd. That's false. 4 is even. So now when we look at this, A or B, is A true? Is B true? Nope, neither of them are true. So A or B is false. Okay, so what we're really essentially doing here is we're comparing two different concepts and saying whether one is true or the other is true. And if that is the case, then we can say that the whole thing is true. So if I'm going to define this a little more clearer, we can say A or B is true when either A is true, keyword or, B is true. Okay, and this is called a union. So a union is that combined region. Where one or the other is true. So what does this look like in terms of an inequality? So I've given you a nice table down here that sort of describes all this definition put together. So in words, let's start actually with notation here. Let's take a look at notation. So we'll start with this middle column. So my notation looks like X is less than 1 or, keyword or, X is greater than 3. That means X could be something like -7, 0, -1, etc. Or it could be something like 4, 5, 7, etc., right? It can be either one of those pathways. So when I go to the graph, you'll notice that, and I'll use a highlighter, that this is graphed here, and this x is greater than 3 is graphed here, and they're both pointing in opposite directions because one goes one way or it goes the other way. Those are the only answers that are possible. So if I were to look at this value right here at number 2, that value of 2, that would be the false in that truth, right? That can't work. It's not less than 1. It's not greater than 3. 2 does not work, so that's why it's not part of the graph. Okay. The other example is when we have an equal to as part of our compound inequality. I'll highlight again here. I'll highlight that this x is less than or equal to 1 is right here. And that this x is greater than or equal to 3 is right here. And they're going opposite directions. And the big difference with this one is that we've got those equal to symbols underneath. And so we have to have brackets or we can have open circles. So if you want to go ahead and add that this could be an open circle going to the left and an open circle going to the right. This would be a closed circle going to the left and a closed circle going to the right. Or compound inequalities or unions always go opposite directions. Cover either way. Okay. So let's take a look at the math I'm going to need you to do and before we get to being able to graph the way this indicates. So example 1 says solve and graph the solution. I'm going to kind of scroll down here. Okay, so I've got this big keyword or here between the inequalities. That's what keys me in that, oh, this is a compound inequality. I'm going to have 2 separate different things to look at. And so we're going to treat it that way. We're going to go ahead and draw a line down each one and treat it as solving each separately. Okay, so my first one on the left, negative 10x is less than or equal to negative 50. I'm going to divide both sides by negative 10. However, since this is an inequality, what do we have to remember to do with this little negative sign right here? That little negative sign tells us that we need to, oh, right, we have to flip this into a greater than symbol. So I'm going to have the 10s cancel out and x is greater than or equal to positive 5. When I go down to my graph, I'm going to have x is greater than or equal to 5, and it's going to be going that way. Then I'm going to go ahead and solve the second one, and I'll do that in a different color. I'll do that in blue. If I want to get rid of the denominator here, I've got to multiply both sides by that 3. That cancels out the 3's, and I'm left with x is less than or equal to 3. That's going to give me a parentheses here and an arrow going to the left. So that is solving and graphing the solution. When I want you to write your final answer, though, I need it to be x is less than or equal to 3 or x is greater than or equal to 5. I need to see that word or in the middle of it. Okay, and I'm even going to have you make a note on that. That has to be in your final answer. Okay. That x is less than, oh, it is not less than 3. I have made a mistake. And I'm going to go ahead, I'm not even going to redo the video. I'm going to go ahead and show you where this mistake is. And maybe some of you have seen it and already come up here and said, hey, Mrs. Sherfan, there's a mistake. But here's my mistake. What is 0 times 3 up there? It's not 3. What is 0 times 3? This should have been a 0. See, it's very easy to make mistakes. So all the times you guys make mistakes in class, notice, look, Mrs. Sherfan made one too. So I should have put that on 0 and gone to the left. There we go. That's better. 3 times 0 is not 3. It is 0. So your answer should be x is less than 0 or x is greater than or equal to 5. Okay. Letter B, similar. We've got that big or in the middle. So I know I'm going to be solving 2 separate things. So a line down here and a line down here. On the left, I'm going to add the 9 to both sides. Get 9x is greater than or equal to 9. Then divide the 9 away to get x by itself, and I get x is greater than or equal to 1. So that's going to be here. And then on the right side, I'm going to add the 3. 3x is less than negative 9. Divide both sides by the 3 and get that x is less than or equal to negative 3. So I'm going to put my parentheses pointing that way, and there's my graph of all my possible solutions. When I write my final answer, x is less than negative 3 or x is greater than or equal to 1. Okay. Notice how neat and tidy my work tends to be. I keep things pretty clear. I put a box around my final answer. Make sure your parentheses and your bracket is very clearly a parentheses and a bracket. I can tell that one has round edges, one has square edges. Things like that will really help you be more successful here. Okay. Last two examples for solving, C and D. Notice I've got the or, so that's solving two of these things separately. So on the left side, I'm going to go ahead and subtract that 7 that's in front. Bring down my 3x, bring down the greater. 16 minus 7 is 9. Divide both sides by 3, and I get x is greater than 3. So I'm going to go to my number line. Notice that this number line is going up by 2s. That's okay. I can estimate that 3 is right here and write the 3 in, and then go ahead and put my parentheses on there and graph it. For the right side, I'm going to add 7 to both sides. The 7's cancel, bring down negative 3x, watch your sign. 23 plus 7 is 30. Divide both sides by negative 3, and when I divide both sides by that negative, notice what am I going to have to do to my inequality sign? I'm going to have to flip it and make it, I do that every time, and make it a less than sign. So now that becomes a less than, and so x is less than or equal to negative 10. So I'm going to, just less than, not equal to. I'm going to put my parentheses here, draw my arrow pointing to the left. For my final answer, I'm going to say x is less than negative 10 or x is greater than 3. Okay. And finally, last example, I picked this example because it's just a bit more lengthy. I want you guys to have that resilience and strength to do longer problems. So we're going to go ahead and draw our lines down the middle. On this one, subtract your 3x first. Get that x on the left. 5x minus 3 is 2x. Bring down your plus 6. Bring down your inequality and bring down your 10. Subtract 6 on both sides. You're left with 2x is greater than or equal to 4. Divide by 2 and x is greater than or equal to 2. So I'm going to go to 2, draw my bracket, make my arrow go to the right. On the right problem, I'm going to add 2x over, and this actually has a place where students also typically make an error. When I add this 2x over, on the left, negative 3 plus 2 is actually negative 1. And you may really want to write that negative 1 in, that invisible 1, to help yourself realize there is a negative in front, because that's a really easy place to make a sign error. Now I'm going to go ahead and add my 2 to the other side. When I do that, both of them cancel out. When everything cancels out on one side, we need to remember to put in a 0. Okay, we have to actually write the 0 in, and on the left side, we're going to bring that negative 1x down. Now here's where this gets tricky, is that we're going to divide that negative 1 away. But notice that it is a negative, so what am I going to have to do to my inequality sign? I'm going to have to flip it and make it a less than. So then x is less than 0. Make your parentheses and draw your arrow to the left. And then your final answer would be x is less than 0 or x is greater than or equal to 2. Okay, that is tricky for a variety of reasons. Remembering that when everything cancels out at 0, and when you divide by that negative 1, you still have to flip the sign. Okay. The last thing I want you to be able to do is look at a graph and be able to write the inequality. So I've got on this left side here, I'll highlight in green. So I've got that, that's going to be x is less than or equal to -3. Then I'm going to use the word or. And on the right side, I've got this parentheses going to the right. A parentheses going to the right is going to be my greater than without the bar underneath it and 0. So x is less than or equal to -3 or x is greater than 0. Same thing on the left side. I'm going to see that I've got this first one here, which is going to be x is less than -2, the word or. And then on the right side, I've got this one, which is saying that x is greater than or equal to 3. And that's my final answer. Okay, so this is compound OR inequalities. All right, you guys got this. As always, if you have questions, please ask, and good luck.